What we're going to look at today is partitioning a segment. If we read through the example, it says that the coordinates of the endpoints of line segment AB are A, whose coordinates are -6, -5, and B, whose coordinates are 4, 0. Then it tells us that point P is on line segment AB. We want to determine and state the coordinates of that point P such that when we break the line segment AB up, we have two sections, AP and PB, and those two things are in the ratio of 2 to 3. So let's just kind of talk about something before we get into actually solving the problem. If I have this line segment AB and I put point P on it somewhere so that it's in the ratio of 2 to 3, so AP to PB is in the ratio of 2 to 3. What that really means is that I've taken this entire line segment AB and broken it up into 5 equal sections. There are 2 of those equal sections over here, and there are 3 of those equal sections over here, but in all, altogether, there are 5 equal sections. So, what we want to do is try to find the point on that segment that is going to break it up into the ratio of 2 to 3. What we really want to do is take the segment and break it up into 5 equal pieces. So let's start by plotting the 2 points that were given. The first point was -6, -5. That's point A. And point B is 4, 0, so over 4 and up 0, and that's point B. All right, so now what I'm going to do is I'm going to kind of use my slope, the idea of slope, to figure out how far apart point A is from point B. Now, I'm not going to find the distance or the length of that segment. I'm just going to talk about horizontal and vertical lengths because I can count those out. So if I start at A and I draw a line straight up and straight across, so I'm drawing in a horizontal and a vertical line to go from point A to point B. It looks like to go from A to B, I'm traveling up 1, 2, 3, 4, 5 units. And to travel from this point to B, I'm traveling over 10 units. And that's kind of nice because I need to break this line segment up into 5 equal sections. So this distance right here, if I take the entire length and divide it by 5, because I want to break it up into 5 equal sections, each one of those sections is going to have to be 1 unit. And then if I take this length, which is 10 units, and I divide it into 5 equal sections, each of those are going to be 2 units. So the entire length would be up 5 over 10, but I want to break this up into 5 equal sections. And to do that, I'm going to keep going up 1 and over 2 units. So if I go up 1 and over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, I've now taken that line segment and I've broken it up into 5 equal parts. Now I need to find the point P, which is going to separate that line segment so that I have 2 equal parts on one side and 3 equal parts on the other side, and that's going to be this point right there. That's going to be point P. There are 2 equal sections on one side and 3 equal sections on the other side. So it does say determine and state the coordinates of point P. So the coordinates of point P are going to be -2, -3. All right, and so that's how you partition a directed line segment. So you want to break it up into total number of equal pieces based on your ratio, and then find the point on that segment that will break it up into that ratio. Okay, so for this video, you did pick up a packet in class today. There are not a lot of questions on MathXL dealing with this topic, so I put one question in there just for you to try. And then what I'm really looking for is that packet to be complete. You may want graph paper, so if you do use a separate sheet of graph paper, go ahead and attach that. If you have your own, that's great. If you need to print some off, they do have graph paper online, so you might want to print off a page to use with that. And we'll talk a little bit more about it tomorrow.